Hello, this is the fourth video on electricity and magnetism for classes 6 to 10. Can be used by students of class 10 to review and understand. In this video, we will look at the conductivity of liquids. We will see that liquids also allow electricity to pass through them, and we will construct a electric cell on our own. In our last video, we used a small circuit like this to find out which materials allow electricity to pass through them and which materials do not allow. So those that allow electricity to pass through them are called as conductors, conducting materials, and those that do not allow electricity to pass through them are called insulators or insulating material. When we close the gap using the aluminum wire, the bulb glowed. When we closed it with a plastic straw, the bulb did not glow. And when we closed the gap with a stainless steel spoon, the bulb glowed. So this way we can see that metals conduct electricity. Graphite also conducts electricity, and they are good conductors. They allow electricity to pass through them freely. Whereas rubber, plastic, wood, these do not allow electricity to pass through it. They are insulators, or you can also call them as bad conductors. Now let us find out whether liquids also allow electricity to pass through them. To do that, we use a similar circuit. We have one or two cells connected in series, and then we connect the cells to a small bulb. And there is a gap in this connection. So the wires that are connecting the cell to the bulb, there's a gap here, and these wires, the gap is dipped in the liquid. So if the liquid allows electricity to pass through it, then the electricity flows from the positive terminal of the cell through the wire, and then through the liquid, and then through the bulb and back to the negative terminal. So then the bulb glows because of the flow of electricity. We are going to test water, not just pure water, but water with a few impurities added to it. First, I will check water with a few drops of dilute sulfuric acid added to it. Then we can check water with a little bit of salt, or we can also check ordinary tap water and see if these liquids allow electricity to pass through. So instead of a cell, I'm going to use a device called the battery eliminator. This works just like a cell. If you do it, check this, you have to use a 9 volts cell, which is available in the market. So in this battery eliminator, the red terminal is the positive terminal of the battery, and the black terminal is the negative terminal of the battery. So I have connected the red terminal to the long terminal of the LED bulb, and the other terminal of the LED bulb has been connected to a wire, and that wire ends in an aluminium So it's connected to an aluminium wire. Similarly, the black terminal is connected to an aluminium wire. So when I dip these two aluminium wires in the liquid, if the liquid allows electricity to pass through it, the bulb glows. I have switched on the battery. Now the battery is working. And now I dip the terminals in the liquids. The bulb is glowing. So you can see the bulb is glowing. That means the liquid is this liquid, which is water with a few drops of dilute sulfuric acid, allows electricity to pass through it. You can see the bulb glowing. So similarly, we can check other liquids. Ordinary tap water also conducts electricity. Water with little bit of salt also conducts electricity. Next, we check a different liquid. This is cooking oil in the cup. And I'm going to dip the terminals in the cooking oil and see if the bulb glows. Battery is on. I dip the terminals in the oil and the bulb does not glow. That means there is no current passing through the oil. So oil does not conduct electricity. Next, I'm testing distilled water. Distilled water is water from which all impurities have been removed. So you boil water, collect the vapor and cool it, you get distilled water. I have got this distilled water from a medical store. Okay, so let me check by dipping the terminals. So the bulb does glow very faintly. So distilled water appears to allow a small current to pass through it. Okay. So that is the actual brightness of the bulb, but when you pass the current through water, it glows very little. I can increase the voltage. Increasing the voltage means adding an extra cell in your battery. So you can see that the glow is a little more. So this way we have seen that some liquids allow electricity to pass through them. Water with salt added or a little bit of sulfuric acid, or you can also check water with lime juice, baking soda. All of these liquids allow electricity to pass through them. We have seen that vegetable oil does not allow electricity to pass through it. It is not a conductor. Other oils, coconut oil, petrol, all of these do not conduct electricity. We saw that distilled water does allow a small quantity of current to pass through. The bulb glows very faintly. So even though liquids allow electricity to pass through them, they do not allow it to pass through as freely as the metals do. Their conductivity of the liquids is less than the conductivity of metals. A small amount of current only can pass through liquids. Now, can you guess why we used an LED bulb instead of the filament bulb we used earlier? So the LED bulb can glow even when a small current flows through it, unlike a filament bulb. You remember a filament bulb glows when the filament heats up because of the electric current. Okay, so it needs more energy to glow, whereas LED bulb can glow with very little energy It consumes very little energy and it needs only a small current. So this is the symbol for an LED bulb. It has a long terminal and a short terminal. The long terminal has to be connected to the positive terminal of the battery, and the small one to the negative terminal. This is different from an ordinary filament bulb. So LED bulb works. The mechanism is more complicated, and you can only understand it in your advanced physics courses, unlike a filament bulb, which only glows because of the heat generated. Now, next, can we make an electric cell? We have so far used electric cells, which we bought. So we do, and we opened up an electric cell, the dry cell, and we saw what is inside. But how did scientists make them first? When did they make them? Okay. So around 1790, scientists discovered how to make simple electric cells, and they knew that electricity was being generated because they could feel small shocks from these cells. They didn't have bulbs to check for the flow of electricity. So this principle of the electric cell was discovered accidentally by a scientist called Galvani when he was dissecting a dead frog. So we will come back to this dead frog story later on. Okay. So Galvani thought that the wet frog, the dead wet frog, was necessary for generating electricity, but Volta around the same time discovered that the frog was not necessary. What he discovered was that when you placed two different metals with a liquid in between, a conducting liquid in between, then these two metal sheets or plates, they behave like two terminals of a cell. That means an electric current flows from between these two plates. So these plates are called as electrodes. So in this simple this is a wet cell because there's a conducting liquid between the two metal sheets. So it's a wet cell. We call it as a voltaic cell in honor of Volta. And this has two metal electrodes. One is a copper plate and the other is a zinc plate. And the liquid in between is water with a small amount of dilute sulfuric acid added to it. Okay. So the electrodes are made of different metals. So to understand why, we need to understand some chemistry, which we will do later. So now when you connect these, copper plate is the plus of the cell, zinc plate is the minus of the cell. Connected to a small LED bulb, the bulb glows, showing us that electricity is being generated from this device. This is my wet cell experiment. I have made 3 wet cells. Each paper cup here is 1 wet cell. So in the wet cell, I have water with a few drops of dilute sulfuric acid added to it. And I have a copper plate and a zinc plate. Zinc is a gray metal and it is quite soft. Copper is a pinkish red metal. It's quite shiny. Okay. So now I have 3 cells which I have connected in series. So how can I say that they're connected in series? This zinc plate is the negative of the cell. So the negative of the first cell is connected to the copper plate, which is the positive of the second cell. Similarly, the negative of the second cell is connected to the positive of the third cell. And I'm going to use the copper plate of the first cell as the positive of my battery, zinc plate of the last cell as the negative of my battery. I'm going to connect it to a small LED bulb. Here is the small LED bulb. I have connected the zinc plate of the last cell to the short terminal, and I'm going to connect the copper plate of the first cell to the long terminal, and the bulb glows. This is the bulb glowing with the electricity that we have generated on our own. Okay, so you can see the bulb glow. So you can leave this for a few hours or even for a few days. This bulb will continue to glow until the energy in the cells is exhausted. So we know that all cells eventually they stop working when the energy has been used up. So against the black background, you can see the cell glowing. So this is our own wet cell, a series of 3 wet cells. Here, I'm measuring the voltage generated by these 3 cells using a voltmeter. The voltmeter has a red wire and a black wire, the terminals. So this is a voltmeter and I'm measuring the voltage generated by our battery. So there's a red wire coming out of it. It's a red terminal and the black wire, black terminal. I'm connected since I'm measuring. So this is the measuring device. I have connected the black terminal to the zinc plate, the red terminal to the copper plate, and the voltmeter has been switched on. It has been set to the voltage mode, and you can see a reading of 2.94, so almost 3 volts. Okay, so this is the voltage generated by these 3 cells. We have generated enough electricity to light a small LED bulb on our own. Isn't that exciting? Okay, so 3 cells gave us 3 volts in series. So we will understand later that in series, the voltage adds up. So each cell gave us 1 volt of potential. That we will talk about what is voltage later on. Okay, that I just showed you how to measure this voltage, which was generated by our own wet cell. So every wet cell has 2 electrodes made of 2 different metals and an electrolyte, which is a liquid, conducting liquid. So how does this cell produce electricity? We need to understand some chemistry in order to understand that properly. For now, all we can say is that the cell converts chemical energy into electrical energy. So there are some chemical reactions going on in the cell. We will take a look. When we look inside the wet cell, we can see some bubbles forming on the copper. When you shake the copper plate, the bubbles escape. So there is some gas forming there. So there is a chemical reaction going on. And the zinc plate has become dull and the copper plate has become shiny. So when we remove these copper plates, all the plates after using the cell for some time, you can see that the copper plates, the part of the copper plate which was inside the wet cell has become very shiny. That's because some copper has dissolved from the surface and the surface of the zinc plate has become dull as if some material has been deposited on it. So the wet cell converts chemical energy into electricity. So in this video, we have first seen that liquids, water particularly with some dissolved impurities, conducts electricity, and the LED was lit up because of the current flowing through water. Next, we created a source of electric current, which was a very exciting thing to do. Now, let us just, before we close, see another cell, and what we call as a voltaic pile. It's made of coins. This is a coin battery. It's a stack of which has coins. So I have used 5 rupee coins which contain brass or some amount of copper in it, and discs of aluminium foil. So I have stacked copper coin, then a sheet of wet paper, a paper dipped in salt water. a small disc of paper dipped in salt water, and then on top of it, aluminium foil. And then again, copper coin, wet paper, aluminium foil. So I have stacked. So each combination of copper coin, wet paper, aluminium disc is a cell. So I have stacked many of them. Okay, and so I use the copper coin of the top and the aluminium sheet of the bottom as the electrodes. I've connected it to a tiny LED bulb. So I have connected the aluminium sheet on of the topmost cell, which is under my thumb, and the copper coin of the bottommost cell are being used as the two terminals, plus and minus. Okay, the aluminium is minus, the copper is plus. So you can see the bulb is glowing. So this is our tiny coin battery. It's a pile of cells. This is called as the voltaic pile. We will stop here for this video.